In this video, we're going to be looking at the equations of tangents, right? But before we start, let's discuss or recap what is a tangent, right? So a tangent is basically, let's have a circle here, right? Which is curvature in nature, or which is curved in nature, right? And then there's a point here, né? And then there's a straight line passing through that point, né? This straight line touches the curve only at one point. It's called a tangent. Ne? It can be on a curve. Let's say I have a curve like this, which is a parabola. And then there's a point here, a line that is going to pass through that point there. It's called a tangent. Okay, which is y equals to mx plus c, which is just a straight line passing through one point on a curve. Okay. I guess you now know what is a tangent, okay? So in this case, the question says we need to find the equation of the tangent to the curve y equals to 3x squared at the point 1 coordinate 3. And then they want us to give a rough sketch of the curve and the tangent, okay? We'll just use a graphing tool a graphing calculator to sketch. Most importantly, you need to know how to do what? How to find the equation of the tangent. Okay. So first thing first, they say find the equation of the tangent. You know that a tangent is basically y equals to mx plus c, right? Which means they're asking you to get m, they're asking you to get c of this line, right? Remember, this is the output, then this is the input, ne? So x and y in any equation, they are always known. So in this case, we need to only get the m and the c. Once we know what the m is and what the c is, we know what is the equation of the tangent. Okay, perfect. So to get the equation of the straight line, we are used to using m equals to y2 minus y1 all over x2 minus x1. But that only works if we have 2 points. In this case, we only have 1 point. Okay, so we are going to use the knowledge that we learned in the past 3 videos, that the gradient of the curve is the derivative of the curve, right? So basically, in this case, I know that this graph here is basically f of x equals to 3x squared. We agree? Remember, y and f of x are the same thing. Then I need to get the gradient. Remember, we said the derivative of a function is the gradient of the function. And then which we can all see that is 6x. If you haven't watched the first 3 videos, please do so before you watch this one. You'll understand how we got the 6x. Okay. And then we agree that the derivative is basically the m, right? Is the gradient of the curve at any x value, right? Remember, the gradient of the curve is not like that of a straight line. It's always going to be changing at any x value. So every tangent will have a unique gradient on the curve. Ne? Perfect. So I know that, okay, the m of the tangent, I'll say the m of the tangent, it's 6. I need to substitute a certain x value here so that I can get the exact gradient of this tangent, right? But they say this tangent to this curve is meeting at this point. You know that this is the x and then that is the y. So your x is 1. Do you see it? So you substitute 1 there because the x was there, right? So your gradient of the tangent is 6. Now you can see that, okay, therefore we have y equals to 6. We substitute there, and then we have x plus c, right? And then to get c, it's always simple. Once you get the m, you have 1 point, you substitute that point. Ne? You have the x, you have the y. So the y will come where the y is. So you have 3 equals to 6. Where the x is, you put the x value, 1 plus c. Then we have 3 equals to 6 plus c, because 6 times 1 is 6. Then we can all see that, therefore, 3 minus 6 will be equals to c. Therefore, c equals to -3. Then you also take this and put it back there. You see? Therefore, the equation of the tangent will be y equals to 6x minus 3. Do we see it, ladies and gents? I hope that makes sense. We're now going to move to the next part of this video. Okay, perfect. I'm not going to sketch, ladies and gents. We all know how to sketch a straight line. We all know how to sketch a parabola. Né? If you haven't watched, if you don't know, please go and watch the videos on functions. You'll learn properly how to do this. Né? Perfect. So now I'm going to just be focusing on the equations of tangents and normals. Okay, so let's do the second one. Okay, so in this one, they say we are given this function. We need to determine the equation of the tangent again. Okay, that shouldn't be an issue. We know that they're asking us to get y equals to mx plus c. Right, perfect. Remember, we need to get the m, right? Sharp. Let's write g of x down. G of x is equals to x plus 2, 2x plus 1. I'm going to put 2x plus 1 here again because of that square. Okay, before you can do anything with the curve, you don't need any brackets. So we're going to remove all the brackets, right? Sharp. X plus 2. So I'm going to FOIL here, or to multiply. So it's going to be 2x. Sorry, it's going to be 4x squared plus, in the middle, you are going to get 4x in total, then plus 1. If you were to multiply this and that and add like terms, this is going to be your final answer. Okay, perfect. Now let's multiply in this. So this x is going to multiply each term there, right? So you can see that we're going to have 4x cubed plus 4x squared plus x. Sharp. This 2 is going to multiply each term there. You can see that we're going to have 8x squared plus 8x plus 2. Right. Then now we can add like terms. This is still g of x, remember, ladies and gents. We have 4x cubed. This one and that one goes together, which gives us 12x squared. Then this one and that one goes together, which gives us 9x and then plus 2, right? So that is basically our g of x curve in simplest form. Before you can do anything in calculus, especially finding the equations of the tangent, sketching the graphs, make sure that your curves are in simplest form. So now we can start. Remember, I said the gradient of the tangent, which is m tan, for the tangent, is basically the derivative of the curve, right? So this curve, we're going to derive it. We can see here we're going to have 12x squared, right? And then we can see, okay, we are going to have plus 24x, then plus 9, right? Remember, we said the derivative of a constant is 0. Okay, perfect. So now, once we have that, they gave us the x value of -1. Before I do everything, ladies and gents, we'll come back here. Let's basically get this exact point. I'm going to do it here on the side. Okay. So guys, here they give us the x value, which is the input. We have to find the output, right? So the x value is -1. I can put it there to get what the y value is. So I'm going to look for g. Where I see x, I'm putting -1. which means even here where I see x, I'm going to put -1, right? So here there's x, I'm going to put -1, then there's +2, then there's 2 minus 1 plus 1 squared. You can see that I replaced all the x's with -1, but I just rewrote the equation, right? That will give us the y value. Let's see what the y value will be. So in here, I'm getting 1. And then in here, I'm going to get -2 plus 1, which is -1 squared, which the final answer will be 1, which means therefore the point where they meet is -1 and 1. The point where they meet is -1 and 1. You always need to get a point before you can proceed. Okay, sharp. So now we can come back here. We know that, okay, we're looking at the gradient when x value is -1. So I replace this x with -1. So I'm going to replace all the x values this side with -1. So this -1, there's a square, plus 24. Then there's -1 plus 9. This gives us 12 minus 24 plus 9, which gives us -12 plus 9, which gives us -3. Remember, this is your m of the tangent, right? M of the tangent is this, right? But we know that the tangent is on point where the x value is -1. So we replace all the x values with -1. So the gradient of the tangent is sorted. Once we get that, we're done with this. So now we know that, okay, we have y equals to -3 x plus c, right? Then now I can substitute these two, which is 1 equals to -3 minus 1 plus c. Because this is the y value, that is the x value. So where there was x, I put -1. Where there was y, I put 1. And let's see what this gives us. Here we get 3 plus c. Therefore, we can all see that c will be -2. Therefore, the equation of the tangent will be -3x minus 2. Okay. In this part, they want us to determine the equation of the normal. They're no longer talking about the tangent now. They're talking about the normal. Ladies and gents, you need to know what is a normal. If you know the definition of a normal, then you are sorted. Ne? A normal is a line that is perpendicular to the tangent. What I mean is this. If I have a tangent going there, the normal will go here, right? This will be, let me just put the m's only. This will be m of the tangent. This will be m of the normal. Ne? The normal and the tangent are perpendicular. They meet each other at right angles, which means when you multiply this gradient and this one, the answers must always be -1. Right? So that is the only most important thing you need to know. The multiplication of the gradient of the normal and the gradient of the tangent is always -1. That's it. And you know how to get the gradient of the tangent? If you get the gradient of the tangent, you know that when you multiply with the gradient of the normal, the final answer must give you -1. Okay, now let's get into it. So they give us the curve xy equals to -4. Okay, remember we need to always have y as the subject of the formula. So I have -4 over x. I divided both sides by x. Divide by x. Divide by x. So this x cancels that. Then you're left with that. And then here, remember it's x to the power 1, right? We need to take it up. So you have -4x. Remember when it goes up, it becomes -1. The exponent of the variable switches. Right. Perfect. So now this is still your thing. And then you know that, okay, the gradient of the tangent, right, which is m tan, is basically given by the derivative of this function, which is going to be minus 4 times negative 1, which is 4, then x, and then we minus 1 there, which gives us negative 2. Right. And then you know that, okay, this tangent, right, is meeting the curve when the x value is negative 1. So you're going to take that negative 1 and put it here. Now let's see what does that give us. It gives us 4. Okay. So the gradient of the tangent is 4. Okay. So let me just show you a trick. M tan, it's 4 over 1, right? Remember, if it's just 4, it means it's over 1, which means therefore M of norm, this is what you do. If this is positive, this will be negative. So the signs always are opposite for perpendicular lines. Ne? So this was positive 4 over 1. This is going to be negative. Then these numbers are going to flip as well. It's going to be 1 over 4. Right. You can multiply positive 4 over 1 times negative 1 over 4. You're going to get negative 1 because they are perpendicular. Ne? You need to remember that. Therefore, if I get the m of the tangent, I have the m of the norm. So m of the norm is basically negative 1 over 4. Therefore, I have y equals to minus 1 over 4 x plus c. Remember, my m comes there. Remember, it's mx plus c. Now I can sub in a point. Negative 1 is my x, 4 is my y. So 4, where my y was, minus 1 over 4, then negative 1 plus c, which gives me 4 equals to 1 over 4 plus c. Therefore, what is 4 minus 1 over 4? Let's see. Gives us 15 over 4. Therefore, y is equals to minus 1 over 4x plus 15 over 4. And that is the equation of your normal line. If you found this video really helpful, ladies and gents, please don't forget to hit the subscribe button so that you can be updated as we load more content. And don't forget to share with family and friends. Thanks for watching. Aluta continue. Tango.